Okay, let's look at how you tackle one of these questions where you have some compound reacts with some other compound and you're trying to find the empirical formula, and all they tell you is the beginning mass and the final mass. As before, you will need to know the masses of the two compounds, or three, or however many compounds, in order to find the empirical formula. So I've got the mass of iron right there, so that's pretty straightforward. The mass of iron is 8.73 grams, and the mass of the other compound, in this case sulfur, what we're going to need to do is assume that all increase in mass came from sulfur being added to the iron, which is to say that the entire increase in mass from that to that is sulfur. So, for sulfur, we'll say 16.25 grams minus 8.73 grams will be the final mass. Let's see what that comes out to be. That's 16.25 minus 8.73. Oops, 8.7. Well, it's supposed to be 8.73. That's 7.5. Whoops, that was a mistake on the calculator. 7.52 grams is what that should be for the difference in mass. Mass of sulfur. And just to clarify, that's mass of sulfur plus iron. This is the 16.25, and 8.73 grams is mass of iron only. And that's why this is equal to the mass of the sulfur. Now, my calculator error notwithstanding, had I punched it in correctly, that's the number that would have come out. Anyway, that being given, now I can do this just the same as any other empirical formula problem now that I've got the mass of the sulfur and the mass of the iron. So here we go. 8.73 grams of iron. Let's convert it to moles. I'll do this also. Convert this one to moles, and then I'll find the ratio of the moles, and that's going to be the formula. So here we go. Let's see, 1 mole of iron has a mass of 55.85 grams of iron. And I suppose before I calculate that out, I'll set up the other one too. 7.52 grams of sulfur. And let's see, conversion factor. 1 mole of sulfur is 32.07 grams sulfur. Put these little things on the end of the S to make clear that's an S and not a 5. At any rate, that's the setup for converting to moles. So here we go. Calculations. Again, significant figures are not particularly important here. I'm taking it out to 4, which is just for the matter of convenience, really. Okay, so having now calculated the moles of each element, I'm going to divide by the smaller of the two numbers, so they're both getting divided by this 0.1563. So this is basically divided by itself, so that's 1 mole of iron, and then this divided by the smaller number is, well, let's have a look and see what that is. So I've still got that number on the calculator. Let's divide it by the smaller one. And it's going to come out to about 1.50 moles of sulfur. Alright, so that's the ratio right there. So for every 1 mole of iron, there's 1.5 moles of sulfur. Okay, well, let's write that down. So for every 1 iron, there's 1.5 sulfurs. Well, we need a ratio that has whole numbers, not decimals. So here's what I'm going to do. Let's transform that whole ratio right there, multiplying by 2. That means multiply this number by 2 and this number by 2, which I can tell already that's going to give our whole numbers without a decimal. So if I multiply everything by 2, that's 2 irons to 3 sulfurs. So that's a nice ratio with no decimal points. That's exactly what we want, and what it means is that the empirical formula is Fe2S3. So let's write that out. Empirical formula is Fe2S3. I should clarify that to make it clear what it is. Pardon the sloppy FE, but you get the idea. Okay, well, let's do this. Here are some questions that work the same way. Pause now and work on these. I'll show you the answers. Okay, here they come. Oops, let's see, I had made a mistake on this one earlier and I forgot to get it ready for you guys, so let's quickly fix that. It's 1 copper per 1.5 oxygen, which you times that by 2, comes out to 2 moles of copper for every 3 moles of oxygen, and Cu2O3. So, whoopsies, pardon that little mistake there, but you get the idea, I suppose. And as for the second example problem, I made a mistake when writing this problem, but I decided to leave it there quite on purpose. That way you would know that whether you did it right or not. Because the way this is set up, you should have gotten that formula, even though that's an impossible answer. So if you did this math and got this formula, congratulations. You did it correct, even though it's an impossible formula. Well, all right, that's it.